Could you imagine a world without oxygen? A world where life as we know it ceases to exist? Ponder this chilling prospect not merely as the plot of a dystopian science fiction novel, but a possible future reality, prediction based on extensive recent research. This research, an intriguing study captained by environmental scientist Kazumi Ozaki, presents a bleak forecast for our world. They involve the execution of a staggering 400,000 simulations. These simulations took into account myriad factors: changes in the sun's luminosity, fluctuations in carbon levels, and alterations in Earth's biosphere, to name a few. All these elements blend together, painting a dire picture of a future that we need to collectively strive to prevent. After relentless analysis and careful study, Ozaki and his team arrived at a grave conclusion. As per their findings, our planet's life-sustaining oxygen will, in the distant future, eventually run out. This research isn't just a doomsday prophecy, but a journey back in time, an exploration of our planet's past that allows us to understand its present and predict its future. Earth has had a unique evolutionary journey, a tale of transformation that has shaped our existence. It has already had a taste of an existence in an environment vastly different from the oxygen-rich atmosphere we breathe today. Approximately 4 billion years ago, during a period known as the Archean stage, our atmosphere was a stark contrast to what we know it to be today. It was a time when free oxygen, the life-sustaining gas we take for granted, was conspicuously absent from Earth's atmospheric composition. Our planet was navigating through a stage of its life where the very element that we associate with the sustenance of life was nowhere to be found. Instead, what reigned was a seemingly inhospitable environment, a world fundamentally different from the one we are familiar with. However, it was the Great Oxidation Event, a significant turning point in Earth's history, that took place about 2.5 billion years ago, which brought about a monumental shift. This was the moment when the oxygen levels in our planet's atmosphere started to increase. This transformative event marked the beginning of a new era, primarily due to the emergence of the first photosynthetic organisms. It was these life forms that were capable of producing oxygen, initiating a change that would shape our planet's destiny. It is this journey back in time that teaches us about our past and provides a glimpse into our potential future. Today, oxygen makes up about 21% of Earth's atmosphere, sustaining complex life forms like us. This is a significant amount that allows us, along with many other species, to survive and thrive. However, it's important to understand that this state of affairs, as comforting as it may be, isn't a permanent fixture in the grand tapestry of our planet's history or its future. According to the esteemed researcher Kazumi Ozaki, our oxygen-rich atmosphere is, in fact, not a permanent feature of Earth's environment. At the root of this unsettling proposition is an incredibly common yet cosmically significant process: the aging of the sun, our primary source of light and life. As our sun continues to age, its behavior will inevitably change. It will gradually release more and more energy, subsequently increasing its heat output. This increased solar heat will have profound effects on our atmosphere, particularly on the concentration of carbon dioxide. Carbon dioxide is known to absorb and trap heat. As the atmosphere gets hotter to the sun's increasing energy output, the carbon dioxide present will start to decompose. The decomposition of CO2 is significant because it's a key player in the production of oxygen. Without CO2, oxygen levels will drop drastically, resulting in an atmosphere with 1 million times less oxygen than we currently have. This scenario might seem dire, but you succumb to panic. It's important to keep this in perspective. The changes I've described are going to happen over an extremely long time scale. We're talking about a process that will unfold over 1 billion years. So, it's not an immediate concern, but it's certainly an awe-inspiring reminder of the cosmic clockwork that governs our existence. But don't panic just yet. We have about 1 billion years before this happens. This study is not only a prediction of Earth's future, but also a crucial clue in the search for habitable planets. It represents a significant advancement in our understanding of the universe and our place in it. The team of researchers behind this groundbreaking work have dedicated their careers to the pursuit of knowledge, working tirelessly to uncover the secrets of the cosmos. Their work offers a fresh perspective on how we approach our search, focusing not only on the traditional markers of life, such as water and oxygen, but introducing a wider range of biological signals. The implications of their findings are far-reaching. By broadening our search criteria, we vastly increase the potential for detection. The universe is vast and diverse, and by limiting our search to specific markers, we may be overlooking potential opportunities. The researchers recommend shifting our focus to include a myriad of biological markers. This approach could potentially uncover countless new worlds, teeming with life forms beyond our wildest imaginings. At the forefront of these exploratory efforts, we find cutting-edge projects like NASA's NEXS or Nexus for exoplanet system science. This initiative is the embodiment of the researchers' recommendations, acting as the primary vehicle for their implementation. They're investigating the possibility of life on planets other than Earth, exploring uncharted territories in our universe and broadening our understanding of what is possible. Their key objective is the discovery of new worlds, focusing on finding new homes for humanity. In conclusion, the deoxygenation of Earth seems inevitable, but it's not immediate. As we stand on the threshold of this discovery, we are faced with a daunting yet exhilarating challenge. We are given an enormous timescale of 1 billion years, a period that invites us to embark on perhaps the greatest adventure mankind has ever known. Our universe, in all its resplendent glory and profound, beckons us to explore its hidden depths. Galaxies, solar systems, stars, and planets, unfathomable in their number and variety, await our curious gaze. This colossal journey is not merely an exploration of the cosmos, but an exploration of ourselves, of our resolve and our bounds of innovation. The future we face may be shrouded in uncertainty, but within this uncertainty lies the exciting prospect of discovery. It is a path fraught with obstacles and difficulties, but it also promises a journey of knowledge, growth, and transcendence. What we are embarking on is not just a scientific expedition, it is a fight for survival. The search for another habitable planet is not simply a pursuit for knowledge or a testament to our scientific curiosity. It is a race against time, a challenge that goes beyond borders, cultures, and generations. It is our shared responsibility, our shared destiny, to secure a future for life as we know it. We stand at the crossroads of history, tasked with preserving and ensuring the continuation of life. The search for another habitable planet is not just a quest for knowledge, but a necessity for the survival of life as we know it.